Thanks for joining. First and foremost, this is a two-talk segment. So I'll start talking about Couchbase, and Michael will swap with me on stage and tell you everything you need to know about Neo4j. So Couchbase, first mandatory show of hand. Who knows Couchbase? All right, well, that's a good thing. Who am I? My name is Laurent Doguin. I'm a developer advocate at work at Couchbase, based in Paris, mostly taking care of the French-speaking communities and the Java communities. Hence, me being here. You can follow me on Twitter. You can send me an email. Don't hesitate. Quick word about the agenda. First, I'm going to tell you a bit about Couchbase, the company, about the architecture of the product. Then explain you what are the three ways you can get data out of Couchbase and how they map to the Spring Data concepts. Then I'll quickly talk about the Spring Data features we have and do a little roadmap to give you an idea of where we're going, because you heard during the keynote that Spring 5 will be a lot about Java 8 and reactive, and our Java driver is using Eric's Java since the very beginning, so we are completely ready. So we'll work a lot with the Spring guys to bring you a full reactive experience for Spring, hopefully Spring 5. So Couchbase the company, it's an interesting mix of two products, so two previous companies. It was Memcached. Anyone knows Memcached? Yeah, a few, and CouchDB. So Memcached was a distributed key value store, and CouchDB was a JSON database, the first JSON NoSQL database. So we sort of merged the two, and we have this interesting product now called Couchbase. That was 5 years ago. Couchbase, the company itself, it's about close to 300 people right now. We have offices in San Francisco, New York, Paris, London, Tel Aviv, Tokyo, Beijing. Quick words about what we do, what our customers do with Couchbase. A lot of profile management. That comes from more of the Memcached side of things, key value in memory store. So when you store a user session, is the sound okay for you? Because I'm getting some feedback, so should we try to fix this and maybe, is that better like this? Yeah? Slightly better? Good. So yeah, profile management. Can we turn the sound down a bit? So actually, if I turn out one of the microphone, works better. Yeah, okay. So, hopefully that will work better. Maybe. So yeah, profile management, session store. When you log in, so when you log into the Apple Store, basically, what's the backend behind this is Couchbase, which is actually pretty cool. That's better. So yeah, when you log into Couchbase, the Apple Store, it's Couchbase behind. So we do a lot of profile session management like this. We do a lot of real-time personalization because it's an in-memory store, so it's extremely fast, which means that we have a CMS called Hippo. Don't know if you know the Hippo CMS, but they use Couchbase to at each query, each page a user load will be personalized to the user depending on his cookies or his previous the previous pages he visited on the website. And they've chosen Couchbase because it's really, really fast. Because again, it's based on a key value in memory data store. Customers 360 degrees view, catalogs, big data, you name it. And there's this, classic big data use case, classic NoSQL use cases. And then there's two less classic big data NoSQL use case, which are the mobile and the IoT side of things. So on the NoSQL, IoT, obviously, you have a lot of connected object that needs to write somewhere. And Couchbase scale more or less linearly, so it's extremely easy for us to sustain a huge writing load like you get when you have a lot of connected objects. And the other part is we have an in-memory database, an in-app database that runs on mobile, or anything that can run a JVM. That's why we do a lot of stuff in the mobile space and the IoT space. That's not the topic of this talk, just know that we have something called Couchbase Mobile that is pretty cool. Couple of customers we have, so as I said, we have Apple, we have eBay, Walmart, Tesco. I mean, you know, if you want to check this out in details, you'll have the slide. That's just to tell you a bit about the company. Now about the architecture. As I said, we come from key value and JSON store, so you can do high availability caching because of this key value in everything. Key value, obviously, like Redis, for instance. Document database. So document database space, think CouchDB, Mongo, and Couchbase. Basically, a document is something you store and that you can query based on the content of what you're storing. So if you store a JSON document into Couchbase, you have several ways of querying the content of the document. And the thing I just told you about Couchbase Mobile, so this embedded database that runs in-app on Android, iOS, or any other JVM-enabled device. And the value of this solution is to sync the content of your local database automatically to the NoSQL remote database. How do you store document in Couchbase? What's the basic unit? Obviously, is document. Documents are stored in what we call a bucket. A bucket is spread across a Couchbase cluster. Cluster is made of nodes. Many different buckets can be on a cluster. So think of a bucket just like a database, basically. How do we store those documents? It's a key value store first and foremost. So every document has an ID. We are going to do hash partitioning, which basically we hash the ID with a CRC32. It gives us sort of an internal ID. And then the bucket is split into 1,024 virtual buckets, think virtual partition. So if, for instance, you have 1,024 nodes into your cluster, you will have one virtual bucket on each node of the cluster. If you turn on replicas, because you're in the NoSQL world, you want to be resilient. If a machine dies for some reason, you want to be able to still have the data. So if you have, for instance, 2 replica, 1 active data set, you have 3 virtual buckets on each node if you have 1,024 nodes. That basically means that we're doing the sharding automatically for you based on that CRC32. So here's a quick example. You have 3 nodes, ABC, you have some virtual buckets. What happens when you add a node because you need to scale up? You have more load coming up to your cluster. So if we add a node, we will trigger a rebalance operation. The rebalance will distribute those virtual buckets accordingly. So now they are all equally distributed into each node. And once you do that, you need to tell the client that the topology of the cluster has changed. So there's this thing called the cluster map. It's basically the list of virtual buckets and tells you on which machine is which virtual bucket. So once you do a key value operation, like give me the document from this key, you automatically know which machine to ask the document to. So it's extremely fast since it's in memory. It's just one network hop, fetching something in memory and then getting it back. So we trigger that rebalance. The map gets updated, get pushed automatically to the client, and now the client knows where to get the document. It also works, so the map has the active data set, and of course it has also the replicas you might have configured. So as I said, in-memory data store, how do you write stuff? Basically, the document is written in memory. You get hands back on the client side, and once it's in memory, it's considered stored. Doesn't mean it's persisted. It goes into a persistence queue. It will be eventually persisted into the disk. It also goes into a replication queue, depending on how many replicas you've configured. If you are doing cross data center replication, which means replication between different clusters, active replication, it also goes into a queue. If you have a query and index service, I'm going to talk more about this, enable, it goes into the index service. But once it's in memory, it's considered stored. And the good thing about Couchbase is that at the operation level, you can actually tune that consistency level. You can ask to wait until the document has actually been persisted to disk or been replicated once or 2 or 3 or 4 times, or been even persisted into 1, 2 or 3 replicas or 4 replicas. So what happens when you do a read? Even if the document is not persisted to disk, it's in memory. With this consistent hashing, you know that each time you want a document, its active data is at one place and one place only, so you know where to get it. So even if it's still in memory, you will have a response even if it's not persisted. So it's really read your own write. So it is extremely strong consistency, which is one of the good spots sweet spots about Couchbase on the SQL world. Here's an example of our new architecture that's coming up in October. You have a node cluster of 6 nodes, and you can see that there's the managed cache, the in-memory thing I told you about, storage layer at the back, the controller. Controller is on every node. There's only one type of node in Couchbase. You don't have to install a master, a slave controller. Everything is into one node. And then there's 3 services. There's the data service, which is basically storing stuff with the key value thing and querying stuff with what we call view. I'm going to talk more in details about views. And then there's 2 services, index service and query service, which are part of a new language called Nickel, which is basically writing SQL queries to query JSON documents into a JSON store. And so when your business is to sell availability, to make sure that when people do a key value get, he has the answer, the response extremely fast, you don't want your query load to compete with your data load. If you're running a big query, it's going to take a lot of time, it's going to take a lot of CPU, it's going to take a lot of memory. This will compete with a simple key value get. So if you're running a session store, you want the fastest answer you can, but at the same time there's a query running, you will have a degraded answer. And you don't want that. You don't want your different workloads to compete on the same node, because then it gives you less availability, less speed. So we came up with something called multidimensional scaling, what basically allows you to distribute those services however you want on different nodes, which basically means you can either scale out, so add more nodes, for instance, for your data service, or maybe add bigger machine for your query service, because it requires a lot of CPU to compute a query plan, for instance. So that's one of the latest innovation you have in Couchbase 4, and I think that's an interesting thing to give you hands-on scaling out or up. So here's what I had to tell you about the architecture. Now I'm going to do a quick Couchbase install. So that's what you get when you install a Couchbase instance. You get through a wizard. Obviously, you can automate this with command lines, or with tools like Chef or Puppets, or whatever you see fit. You can configure where you're going to store the data, where you're going to store the index. You can give a host name, and then you can enable or disable some services and attribute them some memory. So here I'm starting a new cluster. You can import some sample if you want to. We have a beer sample, which is beer and brewery. We have a travel sample. We have a game session sample. I'm not going to import anything today. I'm going to disable the replicas because I only have one node on my machine, so it doesn't make sense for me to have replicated data. It would basically mean I have 2 data on the same node. So I'm going to enable the flush option because I'm doing development, so I'm expecting to be able to flush the content of my buckets wherever I want. I will agree with the term and condition because this is an enterprise version, so I didn't say that. Couchbase is fully open source. There's an enterprise and a community version. This is the enterprise version. There's some slight differences into the features we put into the enterprise version, but all those features in the enterprise version are open source, so basically if you want to build it yourself, you can. Kind of set up password, and then you arrive into the basic Couchbase web UI. It's shipped as is. You don't have to buy anything else. It's really part of the normal experience. So that's how you install quickly just one instance of a Couchbase cluster. I have the list of nodes in my cluster, so just one node. I have a list of buckets. Right now I only have the default bucket, it's empty. Then there's this thing called views, this thing called index. I'm going to talk more about it during the presentation, but now let's go back to the free way you can query stuff into Couchbase. And I haven't started at the right time, sorry about that. So yeah, key value store. What's important to know about key value is that there's several ways you can actually design your keys, and it's as important as designing your documents. If you have a key value store, you don't necessarily have the possibility to actually query the contents of your documents. I mean, that's not true for Couchbase. We have the views, and now we have Nickel, but if you're doing pure key value, which means really focusing about the speed aspect of Couchbase, it's just, you know, one network hop, get something in RAM. It's extremely quick. It's quicker than doing a query, because when you do a query on a distributed system, what you end up doing is scattering the query across all the nodes, then gathering the results, and then sending the result back. So even if you're doing 3 or 4 key value gets in a row, it will be faster than scattering your queries across all your cluster, which is not necessarily true now that we have the multidimensional scaling, because you can have a full index on just one node, and you know, if you have everything you need on the index, then you can just query this index. So 3 ways to query, to design a key: human readable a key. If I'm modeling a user, I can just have the username as key. Could have the email, because you probably have just one email in the system, so that works. It's a deterministic key, so when you know what you're looking for, it's easy to get the document, which is not necessarily the case when you have a computer-generated key. So for instance, you can use a counter, you can use a UID generator. There is no way you can find that document because it's completely random. Right, so what you can do is actually mix this and use compound keys. So basically, my key could be user dash a counter, which is the user counter dash something else, and then you can go even deeper than that. And if you want all the product associated to a user, your key will be user dash the counter dash the product dash number of the product, which gives you the document product, because there's always this thing you need to decide is when do you embed data into a document and when you refer data into your document. It's all about normalization, denormalization, which in the NoSQL world is what you end up doing at one point, asking you this question: how do you, like, you have blog documents, you know that there's comments into a blog, how do you do your JSON documents? Do you have a comments field that contains all the JSON content of the comments, or is it just an array of ID and all those ID are actually another document? So, you know, that's the question you need to ask yourself, and that's important when you're doing your data modeling, so when you're doing your entities, to ask yourself these questions. And then there's this cool thing called, it's a pattern basically called Lookup Documents. So as I said before, if you're doing a query, you're going to scatter the query across the cluster, gather the results. What you can do though is create this user with a random UID. You have no way of getting it because it's random, so you actually create another document with a deterministic key, which is probably, for instance, the email of the user. So, and the value of the document will be the ID of the actual document. So when you want to retrieve the user document based on the email, all you have to do is first get one key value with the email, you get the UID of the document, the random one, and then you can get the actual document, which is actually much faster than doing any kind of query, because again, you avoid the scatter-gather problem. So here's an example of other lookup documents based on the content of the document. Maybe you have a Facebook ID, maybe you have a Facebook username, a Netflix ID, whatever. I mean, you can use anything you want as long as it's part of the document. Drawback with this is if you're doing sort of a manual indexing, well, you have to maintain that index. So if the email if the user changes email, then you need to create another lookup document and remove the old one, which can be extremely a bit complicated. So when you do a key value get with Couchbase, this is not with Spring Data. This is directly with the Couchbase SDK. As I said before, it's fully reactive based on RxJava, so that's how it looks. You first, here I'm getting a document called beer, and then you have this on error resume next, I think, or on error. And what it does is, if the beer document doesn't exist, or if you get an error, you can do another get, and here I'm doing a get from replica. So if the document actually exists, but the node where the active data wasn't available for any reason, maybe because Amazon decided to shut it down, it happens, I can fall back easily because I'm using reactive Rx Java, and then ask for a replica. If you have several replica, you don't really care, just want the first one, so that's why you have the first operators, and then you can do whatever you want with the document. So that's just for an example of reactive thing. And how does this map to an actual Spring Data operation? This is my quick sample I made for this talk. I have an application class, the Spring Boot application class. Notice the auto-config and the Couchbase repositories annotation to allow me to use the Spring Data features. I'm extending one class called abstract Couchbase configuration, which basically allows me to override this free method, get bootstrap host, get bucket name, get password, bucket password. And that's the only information you need from a Spring Data perspective to connect to an existing Couchbase instance. So once I have this, I've created a command line runner. I've injected several things. I've injected something called a Twitter update repository, a Twitter service, and a Couchbase template. In Spring Data, a template is sort of a low-level class used as a base for your repository abstraction. So you can inject it. You can also directly inject the Couchbase client if you want, because if you want to use the reactive stuff I just showed you, it's also doable. So yeah, Twitter updates and Twitter service. The goal of this thing are to store a Twitter update object. What's a Twitter update object? It's an entity that basically represents the state of a Twitter account at one particular time. So you have a creation date, a key account, name of the account, number of followers, number of favorites, number of friends, statuses, etc. Once you have your entity, if you're doing some Spring Data, then you can create your repository. I'm extending CRUD repository because we don't support yet the page and sorting one. Simon, who is the other developer working on Spring Data Couchbase, is fixing this at the moment, and I know I think he's actually writing it right now as we speak. So it's coming. So CRUD repository, basically, each CRUD repository is key value operation, right? Because it's only one document, so it's only one key value get or one insert. So to map this key value thing to concept to Spring Data, I can just use my repository. I can save a new object. Let's say it's a new Twitter update. I could also call my service, but then you wouldn't see everything that's happening. So I'm just creating a really dumb object with sample values. This is gonna get me back my Twitter update object. Oops. And what you do in the key value get, what you want to do maybe is get back that object to display it again to the user because he just saved it, so you want to display him the saved version of the object. So I'm gonna do a get, which is basically calling the find one operation using the clear document, and here I'm making sure that this is actually not null. Then I can run this, and hopefully this will work. So it shouldn't crash, that's the thing. If it crashes, then it means that I think it didn't work. So it didn't crash. So I can go into the Couchbase interface and show you that I actually have a new document here. You can see all the document directly into the interface. You can edit them directly into the interface. You can create some into the interface if you want to. So yeah, that's how it works for the key value stuff. So it's only CRUD operation for one document. What you usually want, what you can also do with a CRUD repository is do a find all and a count, which is basically listing all the documents. Listing all the documents in a key value store would mean that you have all the keys somewhere and that you're doing a bulk get of all the keys and then getting everything back. So that doesn't work. So you need to do a proper query. Proper query with Couchbase. Two ways of doing this. There's the views, and then there's Nickel. So first I'm going to talk about the views. Views, if you know CouchDB, is a CouchDB concept. What it does is allow you to create your own index based on MapReduce function. Each document that's been updated, its mutation is passed into the map function. Into the map function, you can decide, depending on the content of the document, to emit, so to add an entry into an index. So you add another key and maybe another value, because you don't have to just have the ID of the document as value. You could have part of the document, the full document, or maybe do some computation and have an additional view on your data. And once you have this index, the reduce part is I'm taking the whole index you've created and I'm returning you just one object. So if I want to do a find all, I will create a view. The map function will make sure that all the documents, for all the documents that are Twitter updates stored into my bucket, I will actually add an entry to the index. Once I have the index of every Twitter update, if I add the reduce that just return the size of my index, so just one object based on the full written index, then I have the count. That's how we do find all and count into Spring Data Couchbase. So views outside of the Spring Data space, what it is used for, primary index, as I said, if you want to get a list of all your data from key value store, either you know all the keys or you need a way to get the list, so that's what it's used for, just the primary indexing. Then secondary indexes, create an index based on the content of the document, so for instance its type, could be a new index that use a date as key, and for instance the number of followers as value. This view allows you to query depending on the date, so you can do a range query, for instance. I want the document I want the number of followers between this date and this date, for instance, that kind of stuff. So here are some examples, but I'm going to write one anyway, because if I call the find all and the count operation now, it won't work. That's how it looks like directly using the Couchbase SDK. Again, it's fully asynchronous Benelux Java, so you use these functional reactive programming ways, maps, flat maps, subscriber, all this cool thing. So yeah, you can probably check this out. So back to coding. I'm gonna get the list of Twitter updates. And since I'm using Java 8, I can do something fun like this, which you should obviously not do, which is basically printing all the Twitter updates I get from the query. I can also get the count, which is just read count. And then display this. And if I run this, it should fail. And it did. One of the errors is the view Twitter updates all doesn't exist, which is what I just told you about. So how do you name your view based on your entities? Basically, if you have a repository of Twitter updates, then you need to create a new view. So I'm starting with the development view. View are organized into what we call design documents. Basically, it's a way of assigning a thread or some hardware resources to just a set of views. And if the method is called find all, it will look for the all view. So I'm calling it all. That's my view right now. Right, so that's the current. I hope it's big enough. What it does is create an index and add the ID of the document as key and null as the value. And if I show you the results, then there you go. I have only one document, the dummy document I've created before, null as a value. So I want to make sure that all these docs are actually Twitter updates. So I'm gonna do something like this. Check that type is always Twitter updates. And here I can set up my reduce to make sure that my account will work. So I select the built-in count reduce. I save this, show the result. Returns me 1 because the reduce is enabled by default. I had one document. Seems legit. I'm going to publish this view. So the difference between development views and production view, basically the view runs on a subset of documents on development views. You don't want to run a new view on your whole data set. So now if I start this again, it should not fail. And I have my document, and I have the count. If I want to make it a bit bit more funny, I can again use Java 8 to create loads of documents. So that's just a stream as a loop stream. And here you can see that, unfortunately, although I've created all these documents, it returned to me count, one, and only displayed one document. This is because for now, the default consistency level doesn't wait for all the updates you did to be persisted in the index, so your MapReduce to be updated before giving you the answer. So what I can do is actually trigger a global, configure the global consistency level by overriding this protected method called, I don't remember, default consistency. That makes sense? And now I can decide that I want to be extremely consistent and read my own right. So if I relaunch this, it will actually work. There you go. So that's the way of doing tenable consistency on a global scale. And if you want to achieve this on a per operation basis, you need to use the lower level API that we provide through the Couchbase template or directly through the Couchbase client if you want to. Oops. 30 minutes? No, 15 minutes. Okay, so I had planned to show you a custom reduce, but I will actually go back to my slides and tell you a bit more about Nickel, which is this SQL document language. First by showing you what a query looks like, and as you can see, just select stars from somewhere, where something. This is ANSI 92 SQL, so if you know SQL, you can query the contents of all the JSON stored into Couchbase, which is great. So that's why I don't have much more slide about this, because when you all know SQL, the only additional slide I have about that are what we've added to SQL to make sure that you can query all those JSON objects, because when you're doing SQL, all your columns are normalized and the types are not a JSON object or a JSON array. So we need something to get into those JSON array and those JSON objects. We need something to do joins, and we're a key value store, so we have several cool stuff we can do. So additionally to the SQL ANSI 92, we have the use keys, keywords that allow you to query based on the key of the document, which again is much faster than maintaining another index and scanning the index. We have joins, so we're the only NoSQL store that has joins natively in the store. Don't have to use something like Spark or Hadoop or anything like this. It's right here. So it allows you to join, basically, one document. Right now, it only works on primary keys. So if I take my blog example again, you have a blog document, you have a comment field. This is an array of ID. ID corresponds to another document, which is the ID, one particular comment. So I could do a join based on this. I could join all these comments based on all the ID I have on this array field. That would work. Then I have two interesting keywords called nest and unnest, which are basically, if I want to nest my comments into my blog, either they are normalized. So I have the comments blog, I have the comments document, and I have one blog document. If I use nest, I will actually get only one document instead of having the array, because I've nested the documents. I will get one blog document with all the comments in, which is actually what you want to do when you're displaying the blog in your application. You want to have everything as is. You don't want to do several queries to your database. You want one object. That's how you do it. A nest is the other way around. If you want to flatten this, then you can use a nest. So you can use join, nest, and nest as much as you want to a single query. Quick word about the data type we have with Nickel. Basically, this is all the type you have with JSON, so number, strings, JSON object, JSON array, all this stuff. And since it's a JSON store, there is no schema. So one important thing we've added was the is missing a keyword. You could have a field with a null value, that's okay with JSON, but what if you don't have this field in the JSON document? You want to know that because you will be storing different kind of documents. So in your queries, you want to identify them, and that can be one of the discriminants if the field is missing or not. As we are a key value store, you don't have to store only JSON documents. You can store binaries. So some of the use cases we have were for the session store, and that's actually the angle we're going to do with Spring Session. You can store a session directly as a serialized Java object as a value, which means that you cannot query it anymore, but then it will be extremely fast and small. So yeah, let's move on a bit. Some expression we've added. You have functions to manipulate dates. You have functions to see if one particular name is in a JSON array. So like an in keyword, we have a way of traversing the JSON object. So if you have a nested object into the objective store, you can actually access them directly into the query. Basically, everything you need to be able to query JSON. That's another example. You've seen me before for the views create the view manually into Couchbase. And here it's an example to manually create an equal index, because you actually have to create a primary index first. This is extremely close to a traditional SQL database. You have to do the operation of creating the index. You can do it either programmatically, or you can do it by hand, which is what I'm going to do right now. I'm going to create my index. I just need to find my CBQ. That should actually be this one, which is that's better. So here I'm in a shell, an equal shell, so I could actually type directly an equal query. So I'm asking him to give me all the content of my default bucket, and it doesn't work. It doesn't work because we don't have an index. So what it's telling me is you need to create a primary index. So that's what I'm going to do. Oh, that's what I'm doing. Thank you. Success. I have my index. So now if I run this query again, it will give me the content of my bucket. So everything can be made automatic. We just didn't have the time to do it. This is in the roadmap. Instead of having you to create an old view that you can do programmatically, because basically it's just a check on the type of the document or the underscore class value used by Spring Data to know what entity you're actually storing. This will be made automatic. So yeah, I can do different stuff like this. I can select just followers to just, instead of return me the whole document, just return me one JSON object with the followers. You can do add a close function where followers greater than 1, for instance, which is basically, so you should probably do something like this, which is less response. So you can create your own JSON views based on the documents using Nickel, which is again a great thing. How does this translate to Spring Data? So in the Spring Data repository, you know that there's a query derivation based on the name of the method you're going to add to the repository. Then it will implement everything for you. And so all the query derivation are based on Nickel. The find all and count are a bit specific, they are based on views. All query derivation is based on Nickel. I'm gonna get a quick example of here. Method doesn't exist, that's okay, I can create it. Create a method. It's an iterable of Twitter dates. So find by followers greater than, order by followers descending. Find all the followers greater than 1. Well, let's say greater than and then I'm going to print them all. Which is hard to see when you have some stuff going up there. Rerun that. Interestingly enough, that didn't work. That's better. So yeah, query derivation works and it's based on Nickel. If you want to run, because we don't have support for join, nest, unnest, if you want to use all the cool stuff we have based on Nickel, you can always add directly the query annotation, and you could directly type your query in. That would work. Okay, so that's about the Nickel stuff. If you want to do to control your consistency not on a global level, like I did with overriding this method, then you need to inject, either use the Couchbase template as the query Nickel or query views method, which uses the Couchbase API directly, or inject the Couchbase client directly. That works too. All right, so going back to the slides. Oops. If you want to try Nickel, it's there. It will be on the slide. You can check it out. I invite you to check it out. It's extremely powerful and extremely cool to do just SQL queries and join on a JSON store. So a quick word about Spring Data Couchbase, which is basically all the thing I've showed you. We have automatic configuration through this abstract class that you can implement. We have query derivation, tunable consistency on a global level, on a per operation level. I hope we're going to come up with an annotation that allows you to add just one query, decide of the overwrite the global consistency level, because I think that's important when doing a document application to have the strongest consistency. The basic use case for this is someone just wrote a new document in the web app, then you either display that document, which is easy when you do read your own write and key value, or you take him back to the list of parent documents, for instance, and you want the result to be there because you just created it, so he's expecting it. to be on the listing. So that's why we are pushing to have the strongest consistency level, and we are the most consistent NoSQL data store there. But then sometimes you want to be faster than consistent. So, and that should be, from a document app point of view, not the default. That should be something you actually decide, because then you're expecting to have, let's say, weird behavior for the user. Like, I just created something, why is it not on the screen? That's what I will call a weird behavior, and that's why this is not the default. This is something you have to specify. And then, as I said, you have low-level access directly to the Couchbase underlying Couchbase API. So the good news is we are ready now to be fully reactive, and we're going to drive a test project with Oliver and the Spring Data guys to come up with the first Spring Data store that's fully reactive. We're already talking to several Spring pivotal people about that. So that's going to be part of the roadmap. Short-term roadmap, page sorting, it's almost done. Geospatial support, because you can actually create geospatial index. It's not just geospatial, it's actually multi-dimensional index. That is actually already supported into Couchbase. So if you use the whole level API, you can actually do geospatial or multi-dimensional queries. So it's coming. I'm working on the Spring Session implementation, which is not necessarily tied to Spring Data, but it's coming. And then maybe Spring integration, maybe some other stuff. We'll see. If there's something if you actually like what you just saw and there's something you want, just ping me and we'll try to boost that. Our goal would be to be one of the default store for Spring 5, because if everything is reactive, Couchbase is reactive from ground to bottom, so that will be our goal. Some things I wish I had some time to tell you. We have Couchbase Mobile. I did talk a bit about that. We have this extremely cool thing called CBFT for Couchbase Full Text Server. So it's basically, there's a project called Believe. It's an open source project maintained by some guys at Couchbase. It's an equivalent of Lucene written in Go, and that's what we'll be using into Couchbase Full Text Server. So it will basically allow us to do some almost Elasticsearch-like features, so just full text search based on the content of the JSON document. So that's already available in developer preview. You can actually test it, and you are more than welcome to do so and give us your feedback and impression. This is still pretty new. Thing that's been built with Couchbase and Spring, some examples. There is the Spring Session thing. There is a Couchbase importer based on Spring Boot. I mean, there's different apps you can look into. And then there's this cool thing, if you're into big data, we have a Couchbase Spark connector, so we invite you to check it out. It's also in developer preview. We want more feedback before making it GA, so if you have the time to send us something, please do. Thank you very much for having joined me for this session. And now I will leave Michael, because I've slightly over my time, and I will stick at the end. If you have questions, please come and ask me questions. Thank you.
All right, welcome to my talk on in-flight asset management with Spring Data and Neo4j. This is effectively a Spring community user story that comes out of the real world, out of a real world project, and that is leading us from an early problem domain to a concept, to design decisions that we made, and to the final implementation. And of course, how we ended up with writing a lot less code, and I mean a lot less code than we initially expected. All right, before we start with the actual topic, a few words about us. I'm working for Lufthansa Systems. Lufthansa Systems is mainly known as an IT service provider for airlines, not only for the parent company Lufthansa, but also for airlines worldwide. And you usually expect our solutions to be in the form of like revenue management for airlines, flight route optimization, baggage handling, crew management, and in the late history also Inflight-Entertainment system, which puts us into the picture with dealing with real passengers. We do have branches all around the world, so we are in global reach of our customers. When speaking about me, I'm Michael Wilmes. I'm working at the Board Connect department of Lufthansa Systems, and this is effectively the department that deals with our new project and our new product, Inflight-Entertainment system. And we call that Board Connect as well. So you can just mail me after the conference. You can also find me on Twitter. All right, before we go to the problem domain, we first have to check out what the actual use case is. When talking about in-flight entertainment systems, you often have in mind like the things that you know from long-haul planes or long-haul flights, where you have the in-flight entertainment system installed in the back of the seat, and well, of course, there ran cable throughout the cabin, and you have a box underneath your seat. Then that's tampering with your space there, right? And if it's booting up, you see that Windows CE boot up screen from 2004 or something. So it's not that what we were after when launching Board Connect. We effectively have a data center in the aircraft. I think it's actually the fastest data center in the world, at least in terms of physical motion speed. And of course, we are in the actual real cloud. So it basically is, oops. You can get your device out of your pocket, your iPhone, your iPad, and then you can take part in the in-flight entertainment system, consuming content, watching video on demand, audio on demand, flipping through e-journals and things like that, or even do shopping. That's what we present to the passenger. On the aircraft itself, to cater for that, we do have a server installed, of course. We do have a wireless access point so that you can connect with your portable devices. And that brings, of course, also a win situation to the airline, because they don't run cables anymore through the aircraft. It's less costly, and less weight means less fuel that's going to be consumed for your entertainment. And this brings also in-flight entertainment to a whole new perspective, mainly being also available on mid-haul or short-haul flights where you normally would not expect a in-flight entertainment system. Well, this looks like perfectly fine from like 10,000 feet, but if we look behind the curtain on what we needed to make possible behind the curtain, this presented us with a challenge, because it's not only the things that you see in the plane or that get installed in the aircraft, it's also back-end processes that make all this possible. So the challenge was, we have lots of assets, as we call them. We have those physical assets, we have the planes, we have the things that get installed in the planes. We do have media assets or digital assets like those magazines, the video content, the audio content. Then we have like virtual assets. You pack those video sets or combination of content into packages, or we could also call that container, but I think that container thing is now a bit blocked with Docker. So it's a virtual package then, and we refer to that as an asset as well. You cannot just play back video content in public. They come with the license being given by the Hollywood studios, so we need to keep track of that as well. So the whole picture really blows up when looking behind the curtain, and and additionally, these things are not static. Some of those assets that we deal and that we manage change on a daily basis, so we need to keep track of that. So when looking at those things in an early stage of our product development, we already had a quite diverse domain model. This is one of the first that we came up with. So lots of things being packaged into other things, or related or constrained by rule sets. And what we have in place, like, yeah, I think a lot of other customers have as well, is like scoped applications, scoped services that deal with part of your big picture. So we have the content management system that says, well, I know your media assets, I know like what the description of your movie is, things like that. But if you ask me like where this gets all installed in your product, I'm out of the game, right? So that's how you normally have scoped services that deal with parts of your processes and make them happen. That is quite good and it's common, but how do we answer questions that come up that target the whole scope, right? You have a microservice that says, well, am I safe to delete this file that I'm currently seeing on the file system? Am I able to just do that because this, I don't know, it's out of my boundaries, and we didn't want to have like this little poor microservice needing to know like which combination of other services it needs to ask to get a valid answer. So our idea was that those services have a helper application up there that keeps track of the state of the big picture, like how all assets are related together. And so we wanted something where those services could say, like, my little part of the big game changed, here is what I have, and please embed this into your big picture and make this available for other services. So the core objective, if we make it short and precise, is decision support for humans and machines. So we do have services that want to get a valid answer, even if the question is like a global one or goes through your whole domain model. And certainly, if possible, we want to also have like insight on what we actually have flying out there for humans, which is basically our operations and people involved with the product, that they know what is out there and how they can handle this. And this comes especially to importance when we have we're like out of the comfort zone. Normally you have your product and it's managed by you and you control the life cycle, so you're perfectly fine. But in our case, we are the service provider of the Inflight-Entertainment system, but naturally the things that get installed into the aircraft are completely to the stake of the airline itself. So if they decide that they want to switch components in the aircraft because they vaguely suspect anything being problematic, they just do. And we need to keep track of how our product changes out there. All right, so to start up with, we said we need an attitude. And that's what I'm talking about now. It's just a single slide. We need rules of play on how we attack this problem domain. And if we want to have a helper application up there that keeps track of the big picture is only big picture if you say we want to radically include every aspect of our product if it's like really part of the product and if it makes sense. So that was our attitude going forward. We then checked on what are actually our requirements in finding a solution for a problem domain. I think some things might sound familiar to you, some things are really prone to be special for our use case. So we wanted to have something operational, a real-time access to this big picture. We said that we might eventually want to have a horizontal scale out, but the data volume wasn't a problem. At least we thought that, and it turned out to be true. But we still had it as a requirement. We wanted to have a constant performance regardless of query depth, because naturally we had that case. You say you have cleanup job, you want to clean up, and you want to know, am I safe to delete this file that I'm currently looking at. So this query to find a valid answer might span the whole domain model, and we didn't know at the beginning on how much joins we will end up with. So we explicitly made this a requirement to check for proper data persistence technology that helps us with this. All right. How did we go forward? We had an existing infrastructure, like those scoped applications that are already existing around that asset management that we wanted to implement. We have the aircraft data feed, so as soon as the plane touches ground, the aircraft dials back home to our data center and says, I'm an aircraft, I have your product on board. If I look around, I find this and that kind of components with the serial numbers, things like that. So this is the inventory that I can contribute to the big picture, and this gets fed as an event to the message broker, and we participate onto this inventory events, and we add it to the big picture. On the other side, we have media libraries where all the movies are stored. They play their part in submitting inventory information and state of assets. We do have a little CMDB part in the game. We have the content management system in a classical, traditional sense that also submits state information. Some miscellaneous ETL was planned at that stage and also contributed. So once we have that helper thing in the middle that keeps track of the state of the big picture, we want to make sense of it and be able to get this out to the services and to humans. So we have basically two outputs there. We have the RESTful APIs so that services can ask their questions and get a proper informed answer. And we also have like an expert system kind of a GUI that's facing towards our operations so that they can just pick a starting point in our product and then going up or down and seeing what is currently flying out there. All right, so that is sort of the problem domain scope. Now we reach the part where we actually searched out for technical solutions. We were a bit familiar with the Spring framework, but for example, my knowledge wasn't really up to date with how Spring evolved. But from looking at what Spring was after, we immediately noticed that they're actually targeting today's problems. And if you read that requirements sheet, things were pointing out that we're actually trying to get out of the comfort zone of relational databases and might look into the NoSQL space. We will have the RESTful API topic at hand and enterprise integration topics as well. So we actually are already on today's problems, and we felt that Spring really supports us in there. And we like that lightweight deployment model because that is actually a helper application. So we don't want to install a WebLogic or WebSphere just to get this application up and running. So we like the fact that we can use dependencies and you pack the things and you just get what you packed. So that was a really nice thing to have. Spring has a great community backing, so we felt safe in choosing that. Also, there are lots of other Spring components that we were beginning to look at. So if you want to use that, or most of them require actually the Spring Core foundation underneath. So Spring also serves as a valid foundation there. Then we looked out for the data persistence. So we knew that the domain model is quite diverse. that the queries that we gonna submit against the database weren't really limited in any sense, and we couldn't really say that we won't hit any join hell at some point in time. So we couldn't rule that out, and we said we checked a few databases, but actually settled on Neo4j for the reasons that we don't have that ORM mismatch anymore. We have a big picture that we can look at, and if we look at the database, it's just the same big picture. It's not like something completely different. So that makes up for great transparency, and we like that. Yeah, the majority of queries that we had in the asset management are going along the hierarchy of assets. A few of those queries search for like the immediate neighborhood of an affected or impaired asset. These are quite fine. It's like 1 or 2 or maybe 3 hops around your initial data. But there are also queries on the table where we would say, well, this is an arbitrary amount of joins or like a lot of joins involved. We felt comfortable with the model or the schema-free model that Neo4j gave us. Yeah, I think the first point is already said. The thing that enables Neo4j to be that fast in terms of data traversal through hierarchies or through its graph is that they don't need to access indexes when going from one data or from one node to the other. So the things are naturally linked together even down to the core file system. So this is really like the main drive on why Neo4j is that fast when going from top to down in your domain model. Effectively, Neo4j for us had really like that sense applied that we maybe avoid dead ends, that we hit like a join barrier later on in the development because we couldn't rule that out, and from the nature of the problem scope, we were likely to do. All right, so we settled for Neo4j for those reasons given. We then started the first modeling with our data. And we began, for example, in the aircraft, is that pointer visible? Yeah. We do have an aircraft. The aircraft contains access points. We call them BC access points. The aircraft also contains a server. The server, well, runs under BIOS. We call that an asset as well, a software asset, if you name it like that. The access point also runs for firmware that we need to keep track of. And at some point, we have outward direction that in a server, there runs a build package, as we call it, with the stuff that makes up your Inflight-Entertainment experience for a given month, for example. What we took care of is during Neo4j-based modeling or modeling our problem domain onto Neo4j is that we decided which direction we take. Like from Neo4j perspective, you can go either ways throughout your graph. You can even go in the opposite direction of your outgoing edge. You can also say, I don't care about the direction when querying the Neo4j database, but it makes perfect sense to say, I have like one paradigm on how I model, and we modeled this from a drill down perspective. So the aircraft is like up there on the cloud, and if you go into the aircraft, you have always outgoing directions with things running on the aircraft and things running on those things running in the aircraft. So we have like one outgoing direction all the way down to actually files or licenses for the content. So when starting with the modeling, we notice well this is all nodes and edges, which is perfectly fine in the Neo4j paradigm or how Neo4j actually works. But having a business logic implemented in Java and doing lots of incrementally updates in your Java-based logic, we naturally cried like we are Java developers and we need objects, and we didn't really wanted to like disgrace the advantages with Neo4j by doing a whole new custom direct access layer just to work with that database. So we searched out like how can we gain from the benefits of Neo4j but still leverage the Java skills that we have and not like writing the access logic to your persistence layer like completely on your own. So as we were already in the Spring domain, we checked out Spring Data and Neo4j. And this allowed us to effectively remain with POJOs, like you mess with your POJOs, you update attributes, you delete them, you add them, and you can just save them, and it's going to be saved in the graph database. And with a common programming model that is very familiar throughout the Spring Data ecosystem, you will get that lower level Neo4j template, which already prevents you from lots of boilerplate code, and also for exception mapping. You then gain the higher level repositories for your data persistence layer. You get the benefits of the Spring transactional model, and you also have the application event handlers. They come in handy, for example, if you have auditing needs, or if you need to create your UUIDs whatsoever, or your date last modified needs. You have that after or before save event, and you can leverage those. So this all comes into your application, and you can use that, and that greatly reduces the hassle that you have with your data persistence layer. In this case, it's Neo4j, but we had a lot of talks this week on Spring Data. There are also other Spring Data modules, and the programming model pretty much stays the same. You will notice changes with the annotations, or you notice changes when you actually submit your custom queries, that's for sure. But the general programming model stays the same. And especially when you have a large domain model as we have, this really easifies the whole thing. All right, so to sum it up, it's a high-level uniform access to the persistence layer. How do we use Spring Data Neo4j? We use the POJO magic and the web repositories and everything for like the general work, for the core business logic, for the incremental updates for sure, because we do all this in our Java business layer. If we render things on a front end, well, the graph, if you display it on your web browser, just nodes and edges. And if you don't need your domain entities there, you can just use Neo4j template and be a bit faster on that one, because it's a lower level access. You are then reading nodes and edges, right, and you display them in the web browser. An example on how this thing looks like, if you attended that talk from Laurent with Couchbase, I think this looks pretty much similar. You annotate your POJO domain class with a node entity. You have that graph ID. that the data store internally uses as an identifier of your record. You don't mess with that graph ID, you just give it a place in your domain model, but you should not use that as your primary means of identifying a record. So you have that graph ID annotation. You can specify if you want to have special attributes like cached, not cached, indexed. Neo4j used Lucene under the hood, and when you want to specify the relation to a different entity, then you say related to via, and you give it a dedicated relationship type. This is different from, for example, relational databases. They have a distinct type, and you then decide on whether you want to have a rich relationship with own attributes, or if you just want to tie together two nodes and you don't care about on details for that relationship. In this case here, in that example, we have a dedicated relationship entity where you can then add your attributes that focus on this relation between the two entities. I think, this is the next slide, and it shows the relationship entity. You have that graph ID again, you don't mess with that. You have a start node, one end node. We're going from an aircraft that contains a access point in this case. So you have an end node, and again, now you can have a attribute that says the relation has additional attributes. In this example, I added the date last modified. So since when did this relationship exist, or when was it last updated? Please pay attention that this is the pre-SDN4 syntax. We are not yet upgrading, or we are currently upgrading, but have not yet upgraded. So the syntax might have slightly changed. If you look at the latest Spring Data Neo4j version, it comes with a comprehensive reference manual, and this should you should read that instead for the actual syntax. Spring Data also provides you with the means of repositories for persistence access, or as a bridge between you and the persistence layer. So the graph repository is a base repository. All those crude methods are already implemented there. So we extend that base repository. In our case, we have a BCS repository. It's our data access means for getting servers. So you can specify finder methods by just writing, I have a find by serial, and it returns the server that has been found that has that serial. And you see that there's no query for that. Spring Data Neo4j will auto-derive a proper query for that just by looking at the camel case syntax that is given. If you have custom queries, you can just directly say add query annotation and then specify, in this case, your cipher query, and let it return the server. But effectively, this reduces a lot of boilerplate code and a lot of common code that you would normally need to write, because you actually can focus on exceptions to the rule. Like if you have a special query, write that special query. But the normal save, load, find by attribute XYZ, this is already done. So this is really bringing us forward in terms of the implementation. And we were quite puzzled because we went up to date when we looked at Spring Data and we said, whoops, you define queries in an interface and it magically appears to be there once the context is up. So that was pretty puzzling us, but it proved to be really, really good. We added Spring Data REST to the picture. It picks up where Spring Data ends with the repository. It picks up those repositories and expose them as a ready-made RESTful endpoint. And we needed this because we wanted to have a means of access for other services, and we needed the API for that. And this prevented us from the tedious writing of basic CRUD controllers for your large domain model. This just was there. You add the dependency. You might have 1 or 2 lines of a bit customizing what you want to expose, but basically your RESTful API with the hypertext application language paradigm behind is just there once you boot up your content, and that was pretty amazing. And again, helped us in reducing the amount of code that we need to write. It also integrates with Spring Security, so we have a UI and we have an API. So naturally, you have a different authentication scheme for your API than you have for the UI. With the UI, you have LDAP or whatsoever, and with the API, you can, in this example, we have a very basic authentication, so you can still say, Spring Security, please take care of those auto-generated RESTful API and make it secure by your means. How we use Spring Data REST? We use Spring Data REST for arbitrary access that we give out to the other neighbor services so that they can say, please get me the aircrafts, and then they can navigate down as to their liking. If we have custom aggregations or highly condensed DTO needs that are not like mapping directly to your domain model, we fall back to actually writing controllers for that. But that is then the exception and not like the main task. And even that is now changing when I'm remembering correctly on what Oliver Gierke said about Spring Data and the advancements made. You can now use projection through interfaces as a viable alternative in Spring Data REST. So you don't even need to fall back to write your own controllers. You can do projections through those interfaces. So things are getting better even. We had a few lessons learned. We were new to the Neo4j topic, so we had a few things that we did wrong, obviously. So if you have a graph and you say, well, everything contains like another thing and that thing contains another thing, you effectively have like anonymous edges or anonymous relations between the assets, and that is not helping from a semantical perspective. It is also not helping for the database because Neo4j can filter out relationships during traversal. And if you say an aircraft contains a server and an aircraft contains access points, if you make a query and you only want to have servers as a result, you need to filter them out by saying, well, the end node should be a server. So that can be done, but that isn't the most effective thing on earth. So it is better to say an aircraft has outgoing relationships of type contains server or contains access points. You can put that into your Cypher query, and Neo4j during traversal will magically say, well, this is the wrong relationship type. I don't go that way. I just go the explicit typed way and be way faster. I don't know if that source is correct, but I remember someone doing a benchmark, and that also proved that explicitly typed relations are really worthwhile to have in Neo4j. So let's round this up. We are running a bit late, so we have a self-contained deployment model. After we finished, we have Neo4j running in embedded mode. That was perfectly fine for us. We didn't have that horizontal scale-out needs. We do have Spring Data Neo4j as abstraction towards your persistence layer. We then have the Spring framework, of course, the core framework. We have the custom business logic that solves our problems in Java code with incremental updates, getting all the inward streams handled. We then have Spring MVC in the picture. We have Timeleaf as a template engine and Bootstrap and data-driven documents that enable us to have an internal UI, so a web page where our operational staff or the project people can just move around the big picture that we now created. And we, on the other side, for the machines, we have Spring Data REST in the picture that helps us in serving the API needs that we had to make this value that we have with a global picture and the states of the assets in there to make this available to our infrastructure. And everything is packaged as a jar, so we don't have other dependencies than that, and that helps in running this application. So how does it look like from a human going on to or logging into the front end? We most of the time should know where our planes are, so we look at our planes when they dial home. We can then, now this is a question, what do you think is inside the plane? A graph, of course. So we can drill down from the plane and we can look inside the aircraft, and normally it would display the immediate neighborhood. So this is the plane that we're looking at. We see the things that are installed in the aircraft. The user can then say, well, expand me what is in the server, and then you get that virtual package. In the package, you have like business rules applied, or yeah, in this case, we have the first class, and in the first class, you are presented with, I think, 2 movies, and that happened to be Spring related. What a surprise. So that is what we present as an additional, like, small benefit to the operator, but the main means are making the thing available to our other services in the back end. The funny thing now that we have Spring Data REST in the picture is that this thing, like going through your database, is actually available through the API as well without writing you any code. So that is really, really a nice benefit there. And thanks to the Neo4j persistence, we can also handle the deep queries. And things like that wouldn't be really possible or hardly possible with a different data store. Is it visible at all? I don't know. It actually says, I have that Hobbit movie, and please show me like 999 hops inward dependencies, regardless of how indirect the dependency might end up to be. And with one query, the picture at the bottom right shows that we not only know what is depending on that Hobbit movie, we also get the whole picture on how it is enabled in our product, how this movie is being exposed to public. We have the whole graph at hand with one single query. There are some things that we can drop from our application, and who doesn't like to delete code? I mean, that is really nice to delete obsolete code. We had that jar topic, a self-contained jar. We made that possible with Maven Shade and made an Uber jar, an Uber jar packaging with that. Now that Spring Boot is there, I think it does that, yeah, just better. So we will definitely make that little step and migrate to Spring Boot. And in the meantime, we spawned several Spring Boot-based microservices also in our backend, also within the vicinity of that product. So it will prove worthwhile to have this application also on the fundamentals of Spring Boot. In the past, we manually integrated the HAL browser for the RESTful API, but this is going to be brought into the picture by Spring Data REST. You just add a dependency, and there goes your web UI API browser for testing purposes. So we will remove that manual integration in the long run. We do have, in summary, an 1:10 to 1:30 ratio between node count and relationship count. So we feel that the graph-based approach proved really worthwhile for us. Now we did not yet migrate to Spring Data Neo4j 4, just got released by the GraphAware guys with support from Neo4j and Spring. This is a complete rewrite. The previous version of Spring Data Neo4j were optimized for the embedded use case with Neo4j, which was perfectly fine for us. But for the audience that wants to integrate Neo4j in server mode, they needed this to be there, and it's now been released. They have the OGM, the Object Graph Mapper, separated now. They have fast metadata scanning. They have now a session scope so that you can say, in my HTTP session that I'm currently working at, I want to, by default, not only get like this asset, but also the related assets with the query depth, for example, like 2. And you can define that now per session instead of the fetch annotation we had previously with other versions. Yeah, so Spring Data Neo4j is a complete rewrite, and it says server mode first. So especially suited for Neo4j running as a separate instance. There are huge performance improvements in that mode. And they have smart object mapping, so they only hit the database when actually needed. So please watch out for Spring Data Neo4j 4.x. We will do definitely. We're already on the first migration steps. And well, let me conclude this with thanking Spring, thanking Neo4j for the support. And if you have questions, just do it now, or maybe if we run out of time, just we take those questions offline, and I will be here in the next minutes to answer those. All right, so thank you.